Okay, in this video we're going to talk about inverse functions, rational functions. Okay, so in these problems the first thing we're going to do is find the domain of the original function. And the reason we're doing this because if we find the domain of the original function, that's going to be the range of the inverse function. Okay, so once we find the domain, we'll have the range of the inverse function. Okay, so let's do, if you've watched my other videos on the inverse functions, you should have this part down. We're going to rewrite this as y equals 4x divided by 7x minus 2. Okay, and we're going to switch the x and the y. So x is equal to 4y over 7y minus 2. Okay, so we've got two y's floating around, and we can't have that. We only want the one y. Okay, so here's how we're going to get rid of that. First of all, I'm going to multiply both sides by 7y minus 2. Okay, so if I do that, if I go ahead and multiply this, well, first of all, this side cancels. That cancels. And if I multiply this x, I'll get 7xy minus 2x. That's on the left. So I multiplied this and I went ahead and distributed, equals 4y. Okay, now I want to get all the y terms to be on one side and everything that doesn't have a y term to be on the other. Okay, so I'm going to subtract the 4y from both sides. That'll get the y terms over here, but I'm also going to add the 2x to both sides, and that'll get rid of the x term over here. Okay, so on the left side, this cancels out, and I get 7xy minus 4y. And on the right side, the 4y cancels out, and I'm left with 2x. Okay, so we still have two y's floating around. Here's how I get rid of them. Both of these terms have a y in them. So I'm going to factor out a y. Now, if I factor out a y, the 7xy becomes just 7x. And if I factor out a y here, out of negative 4y, then I get negative 4. Okay, and on the other side, I have 2x. Okay, now I can get y by itself by just dividing by this 7x minus 4 on both sides. Okay, so that leaves me just the y. So I'll say the inverse function, h inverse of x, is equal to 2x over 7x minus 4. That's my inverse function. Okay. All right, so I found the inverse function. Now I need to find the domain of the original function in order to find the range of the inverse. So the domain of the original will be the range of this one. Okay, how do we find the domain? The domain of h of x is equal to 4x over 7x minus 2. Okay, well, all we have to do is figure out what the domain can't be. And since this is a rational function, so long as everything works, so long as the denominator is not equal to 0. So that's what we're going to force to happen. We're going to say, well, let's figure out what number will make this denominator equal to 0. We'll leave that out and make everything else good. So add the 2 to both sides. We get 7x equals 2, and x is equal to 2 over 7. So the domain of the original function is going to be from negative infinity to 2 over 7, union from 2 over 7 to positive infinity. Okay? So keep in mind that that's the domain of h of x. So the range of h inverse of x is this. Okay? So the domain of h of x is the same thing as the range of h inverse x. Okay, and in order to find the domain of the inverse, we do the same thing. We take the inverse and we set the bottom equal to 0. So 7x minus 4 equals 0. So 7x equals 4, and x equals 4 over 7. So the domain of this one, domain of h inverse of x, is equal to negative infinity to 4 over 7 union 4 over 7 to infinity. Okay, so we found the range of h inverse of x, and we found the domain of h inverse of x. Okay, so let's do another one. Out of room on that, so I'll just use a different piece of paper. All right, so the same thing here. So I'm given f of x is equal to 2x minus 7 divided by x plus 6. Okay, so I want to find the inverse, and I want to find the domain and range of the inverse. Okay, so first of all, I didn't do this first last time, but let me do it first this time. Let's find the domain of this original function. Okay, so the domain will be everything except for whatever makes the bottom of this 0. Okay, so if we set x plus 6 equal to 0, we get x is equal to negative 6. So my domain is good for everything except for negative 6. So my domain is from negative infinity to negative 6, union negative 6 to infinity. Okay? Keep in mind that the domain of the original function will be the range of the inverse function. Let's find the inverse function. So y is equal to 2x minus 7 over x plus 6. Okay, we switch the x and the y, so x is equal to 2y minus 7 over y plus 6. I'm going to multiply the y plus 6 to both sides, which will make it cancel out on the right. And on the left, we get x, y plus 6x. And on the right, we get 2y minus 7. Okay. So these two terms right here have y's in them, and these two don't. So I'm going to move this 6x over here with this negative 7, and I'm going to move the 2y over here with the xy. Okay. So I'll subtract the 6x from both sides, and I'll also subtract the 2y from both sides. So I'll get xy minus 2y on the left, and then I'll get negative 7 minus 6x on the right. Factor out the y, like we did last time. You get x minus 2 is equal to negative 7 minus 6x, and then divide the x minus 2 on both sides. It'll cancel here. So that gets y by itself, which means that's the inverse. So f inverse of x is equal to negative 7 minus 6x over x minus 2. Okay. So the question was to find the inverse and then find the domain and range of the inverse. Okay. So the domain of the inverse can be found by setting the bottom equal to 0 and then leaving that number out. So x minus 2 equals 0. X equals 2. So my domain will be everything that's not negative or not positive 2. So negative infinity to 2, union 2 to infinity. My range will be the domain of the original one, which is this. Okay? So my range of the inverse is this right here. So my range is equal to negative infinity to negative 6, union negative 6 to infinity. Okay, let's do one more. Okay, so for this one I have g of x is equal to x divided by 9 minus 4x. Okay, so first of all, let's find the domain. The domain of a rational function means you just set the bottom equal to 0, find that x value, and then leave it out. So let's subtract the 9 to the other side. So negative 4x equals negative 9. Divide by the negative 4. So negative divided by negative is positive, so x is equal to 9 over 4. So my domain is from negative infinity to 9 over 4, union 9 over 4 to infinity. And that will be the range of the inverse function when we come back to it. All right, let's find the inverse function. So y is equal to x over 9 minus 4x. Switch the x and the y. X is equal to y over 9 minus 4y. Multiply the denominator to the other side. So multiply by 9 minus 4y on both sides. Okay, it'll cancel here. So we get 9x minus 4xy, that's when I multiply this through, equals y. Okay, so let's move this term over because it's the one that has the y in it. This one can stay where it is because it doesn't have a y in it. So add 4xy to both sides. So you get 9x is equal to y plus 4xy. Okay, factor out a y, and you get, let's see, when we factor out a y from a y, it just leaves a 1 plus 4x. And then divide by the 1 plus 4x. So we get y by itself, so I'll call it the inverse, g inverse of x, is equal to 9x over 1 plus 4x. Okay, that's my inverse function. Now I'm asked to find the domain and range. I've already found the range because we found the domain of the original. So this is going to be the range of the inverse. Okay, the domain of the inverse, we just set 1 plus 4x x equal to 0. So 4x equals negative 1. So x is equal to negative 1 over 4. So the domain is from negative infinity to negative 1 over 4, union negative 1 over 4 to infinity. The range is what we already found to be the domain up here. So the range is from negative infinity to 9 over 4, union 9 over 4 to infinity. And that's it.